Hello everyone, I am Rishika. My teammates are Neha, Kumari, Sweta from Department of Electronics and Communication Engineering. We are the second year students at BVRAT, Hyderabad, Telangana. We are doing internship at Ematex Information Technology based on embedded system. During this internship, we have built a project called microwave oven. So these are the topics we have learned during this internship. Introduction to embedded system, introduction to C, conditional statement, loops and operators, arrays and pointers, storage classes, preprocessor, functions and strings. And to implement the project we need MPLab, IDE, XCS, PixMLab, introduction to various peripherals of PIC C1716F5778. And we move to contents. Introduction, embedded system, block diagram, requirements, embedded C program, Pixem Lab, CLCD, tactile switch, matrix keypad, ISR, timer, and the most important one is project implementation. And introduction. What is a microwave oven? A microwave oven is relatively small box-like oven that rises the temperature of the food by subjecting it to a high-frequency electromagnetic field. What is the purpose of microwave oven? A microwave oven are common kitchen appliances and popular for reheating the previously cooked food and cooking a variety of foods. They rapidly heat foods which can easily burn or turn lumpy if cooked in conventional pans such as hot buffer, fats, chocolate or porridge. There are several modes in which microwave oven operate, but in this project we have focused on 4 modes which are mentioned below. Micro mode, grill mode, convection mode, start mode. What are the uses of these modes? We will see now. Micro mode. This is the standard mode where the microwave oven uses microwaves to heat or cook the food. You can usually adjust the cooking time and power level to control the cooking process. Next, grill mode. Some microwave ovens come with a grill element that can be used to brown or crisp the top layer of the food. This mode is often used for dishes like carousel to mint or cheese on the top layer of the dish. Convection mode. Certain microwave ovens are equipped with a convection fan and heating element. In this mode, microwave can function like a regular oven, baking and roasting the food with a hot air circulated by the fan. Next, last one, start mode. After setting the cooking time, the power level, press the start on microwave button to begin the cooking process. Microwave will emit the microwaves to heat or cook the food according
Is an embedded system. An embedded system is a specialized computer designed to perform dedicated functions or tasks within a large system. It is often embedded into a device, product, or mission to control specific function. It is not intended for general purpose computing. Embedded systems are typically compact, efficient, and optimized for reliability and real-time operations. They can be found in a wide range of applications such as appliances, automobiles, medical devices, and industry machinery, where they play a crucial role in controlling and monitoring various functions. The examples of embedded systems are used in wide range of technologies across an array of industry. Automatic control systems. Modern vehicles contain a number of embedded systems for the functions like engine control, anti-lock braking system, and airbag deployment and navigation, etc. Next, home applications. Home applications have embedded systems including microwave oven, washing machines, refrigerators, and dishwashers to control their operations and user interface. Medical devices. Devices like pacemaker, insulin pump, and MRI machines incorporate embedded systems to monitor and control medical processes. Consumer electronics. Smart TVs, Blu-ray players, digital cameras, and audio receivers often include embedded systems to manage their interface and process media. Mobile phones. Devices are essentially embedded systems with a powerful processor running with operating systems like Android and iOS. The embedded systems manages phone calls, missions, and apps, etc. Next, we are going to learn about the block diagram of our embedded systems. In this, microprocessor is a main part of our embedded system. Here, the microprocessor input signal is given by the ADC, which is known as analog to digital converter, which converts the analog signals into digital signals, and these signals are given to the microprocessor, and our microprocessor will process those signals, and that can be given to the digital to analog converter, which converts the digital signals into analog signals and given to the actuator. And the processed signals in the microprocessor can also be stored using the memory, and to run all these components we are using the power supply block. Next, we are going to learn about the block diagram of microwave oven. Our microwave oven contains different components because our microwave oven need to perform different kinds of tasks according to the user. And we can see there are different components in our microwave oven block diagram, like a heating chamber, and DC power supply to run our microwave oven. We can see different types of circuitries which help our microwave oven to perform all kinds of tasks. Next, we are going to learn about the requirements. The requirements are MP Lab XIDL, XC8 compiler, PICSIMLab, PIC16F877A microcontroller, 16x4 CLCD, MKB, timer 2 and tactile switch. Next we are going to see the embedded C programming. This program which we have written using the C language, and this program is loaded into a PICSIMLab to make our microwave oven work properly.
The project simulation can be done using the Pixim Lab. Then CLCD. CLCD stands for Character LCD or Character Liquid Crystal Display. It is a type of display technology commonly used in electronic devices. You can use this type of display in various applications like data loggers, etc. And then tactile switch. Tactile switch is also known as tactile button or tactile push button. Is a type of electric switch that is designed to provide the tactile feedback. Then matrix keypad. It is a keypad in which number of tactile switches are connected in row and column concept. This is used when more number of user inputs are required and still want to save some controller. These keypads are mostly used in telephones and calculators, etc. And then ISR. ISR stands for Interrupt Service Routine, and ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to request of interrupting source by clearing the interrupt flag. And then timer. Timer is a component which is extensively used in different embedded systems. They are used to keep a record of time for different events occurring in embedded systems. It has many applications such as measuring time and generating, etc. Timer counter is a software designed to count the time intervals between the events.
In project implementation, the code is executed in MPLab. The file used is main.c, and this, as you can see, this is the code required for our project. As you can see, this is our code. In the code, starting part is done for the initialization. After that, the main, which is used for the functioning, which is essential for our code. In time display screen, we used time, start or resume, pause, stop. These are done. And then next, menu display screen, we used micro, grill, convention and start. Next, in clear screen, which is used for the clearing, then the power on is done. In that we used powering on. Then in next, setup time, temperature, the temperature is done, is set up, and these the functions are required for our project. And then we use the header file, and then on off for our project. And in micro oven, click on. As you can see, on the left side we have projects. Click on micro oven. After clicking on the micro oven, we'll get several options. Choose build. After choosing that, we'll get that build successfully. That means, that indicates that the code has no error. It's absolutely correct and it can be used for our project. After implementing the code, now come to the Pixim Lab and select the file. In that, you select the loadx and then select the micro oven file, open, click on open. Then you'll be displaying the power on micro oven. Then you'll get a 4 options: micro, grill, convention, start. Press 1 to select micro. After that, you'll get power 900 volts, and then you'll get setup time. Now set the time as 2 minutes 6 seconds. After the time is set up, the fan starts rotating, and you'll have 4 options: start or resume, pause, stop. By clicking 5, it will be paused. After the 4, by clicking the 4, it will be resume. By clicking 6, it will be
reset, and you'll get 4 options: micro, grill, convention, and start. To activate the grill mode, click on 2 button and you'll get a display of setup time. Now we'll just set the time 02 seconds, then the fan will be turned on, time up will be displayed. After that we'll get a sound of the buzzer which indicates the cook is completed. Now for the convention mode, select the 3 and you'll get a display of set a temperature. Now we need to select the temperature. You'll get setup temperature interface. I'll be selecting the temperature as 200. Then you'll get an interface of showing preheating and you'll get of time remaining. Afterwards you'll get the interface of set time. Now set the time for which you required. After setting, the fan is on. After the time the cook is ready, you will be getting 4 options: start, pause, stop. By clicking the 6 you will get again the interface showing the micro, grill, convention. To activate the start, we need to choose the 4th button. After choosing, we'll get an interface showing the time, start or resume, pause, stop. After that, by clicking on the 4th option, you'll be seeing that the time will be increasing like that. According to the time required, you need to set the time by clicking the 4th option. Pixum Lab mainly focuses on 4 modes: micro, grill, convention, start. We have all discussed how to activate and deactivate. That's it, and thank you for giving me this opportunity. Thank you.